The 1970s were a very different time from today. These were the last years before the overseas holiday boom, before pastimes, work and music were transformed by computers and new technologies, and BMXs and mountain bikes were a thing of the future. For a city like Aberdeen, it was the start of the oil boom.
This is the story of a new oil production platform in the North Sea.
The talk was of progress and excitement.
Of years of planning and hard work. The contracts, placed the length and breadth of the land, will now bear fruit.
There was hardly a thought about production platforms becoming redundant and what would happen to them a long time into the future. But for some platforms, that future has already arrived. The Northwest Hutton field began production of oil and gas in 1983. 130 kilometres northeast of the Shetland Isles, this was home for thousands of workers over a period of 20 years.
When we were producing, it was a brilliant atmosphere on here. Absolutely brilliant. Good crack, everybody got on with one another.
Some wit has said there's a connection between the production of hydrocarbons and the consumption of carbohydrates.
In 1980, I first started working on the Northwest Hutton project, and then I'm still here now. So I've got a lot of affinity towards Northwest Hutton.
Train 1 discharge, 300.
I've got 3 kids through uni working here. I've enjoyed my job and I've earned some canny money, you know.
Northwest Hutton produced around 126 million barrels of oil, a significant contribution to the UK's economy. But while other fields in the North Sea have kept producing, with many still planning for decades to come, Northwest Hutton did not live up to its original promise.
I think the reservoir has never performed as originally desired and brought us to where we are today.
It stopped production in 2003, leaving only the memories of those who worked there.
Back in 2002, it was realised that the productivity of the wells had gone down. So at that time, it was decided the best thing for its future was to abandon the wells and then decommission the platform.
They had various plans for Hutton. They had 2 super tankers weld it together and lift the rig at high tide off its jacket. There's been plans for a hotel, been plans for a prison.
Decommissioning of a platform is a very complex procedure, and it's a very regulated procedure.
We had to make sure that we consulted with all the correct people, all the government and the non-governmental organisations, to ensure that we were going to remove it in an environmentally sound and safe manner.
You have to firstly make sure that the reservoir is totally isolated from the platform. So you put cement in the wells to ensure that the formations are sealed off, so there's no potential for any hydrocarbons to leak to the surface.
As far as the platform goes, it was in a safe condition as it was possible to make it before the removal work started in earnest.
Starting in earnest couldn't happen until it was settled on exactly how Northwest Hutton was to be removed. It was finally agreed that nothing would be left above the surface, and the legs and pipelines on the seabed would be removed to ensure that nothing remained that could interfere with deep-sea fishing.
In 2008, we're removing the topside structure down to the top of the jacket. The plan is to remove the jacket in 2009 down to the top of the foundations. Then 2010, the pipelines will be decommissioned.
Brought in to do the work was the heavy lift vessel Hermod, operated by Dutch company Harema.
There is a very limited number of heavy lift vessels that are big enough to do this sort of work. Harema is one of the major contractors in the world with such vessels, and the Hermod has the capability to lift the sort of loads that we require them to lift.
The Hermod is what they call a semi-submersible crane vessel. It has accommodation for 371 people.
The Hermod is one of the 3 largest lifting vessels in the world.
So on May the 1st, 2008, Hermod set off for the northern North Sea to begin work taking Northwest Hutton apart piece by piece. It had been standing here unmanned for nearly 4 years. Now, in half that time, it was to be taken away.
This project is really important both to BP and to the industry. This is the biggest offshore decommissioning project thus far in the United Kingdom continental shelf. So it's a real landmark project for both company and industry.
It's the first really big one that's been done, so to be involved in it, It's really exciting, really exciting.
It is exciting in a way, but it's also scary because you want to do a good job, but there are so many uncertainties that you can never foresee before you start a project because you never did something like this. So all eyes are concentrated on this project.
This is the biggest installation that we've attempted to dismantle in the North Sea. We have taken out some minor platforms before. Generally, they've been a single lift.
The platform's going to be 22 lifts. It actually weighs 22,000 tonnes, the topsides. The lifts vary from 300 or 400 tonnes up to about 3,000 tonnes. Obviously, we couldn't take it away in one go because even the biggest herboard crane could only take 5,000 tonnes.
I'm sure that some of the newer platforms that went on as much larger lifts could also come off in larger lifts, but not North West Hutton.
The platforms weren't designed in such a way that they could be easily decommissioned and taken away.
And gradually it was all coming together. Modules and derricks, cranes and helideck, plus 100,000 other items of equipment.
I know we've learned a lot since those days. So when you're looking at North West Hutton topsides, it wasn't as simple as saying, well, we put them on that way, we can take them off in exactly the same way.
It is a challenge for us because we are building most of the time the platforms. Now we have to take them apart.
The structure's been out there for some 26 years. It may have been subject to modifications. Areas of the structure may have deteriorated.
The guys really planned these lifts very, very well, and they were done in a very controlled way over days of planning before the lift happened, making sure all the cuts were in the right place, and then lifting out. It's all very controlled.
I actually seen the flare though, and that was a very interesting lift. The flare, not so much with weight, but by the geometry of it. They had quite a tricky procedure to set up for the flare.
The flare boom will be picked up at an angle and taken out away from the platform.
They'd done it first time, and they'd done it very, very professionally. And it gave us confidence for the rest of the lifts throughout the campaign.
Normally with a heavy lift, you have something that you've just made, it is brand new and shiny, it's coming out of a fabrication yard, you are absolutely confident of its integrity, it's pre-slung, and you have to lift it up with a heavy lift vessel and put it in position. We've got the opposite problem here. We've got to make sure that whatever we're going to lift has sufficient integrity to stay in one piece when we lift it, and it's actually been cut free from everything else. So when we come to lift it, we're lifting the load we intended, not the load plus a platform attached to it.
To carry out a lift, first of all, a structural analysis is done to determine the correct points to obtain a center of gravity. When that's worked out, the geometry, the size, and the strengths of the lifting aids have to be calculated. That is where the pad eye comes in. The pad eye is a piece of material with a circular hole. We basically weld 4 pad eyes at strategic locations on the unit. After these are put in place and non-destructively tested, the lifting hook is attached. The lift is then carried out.
On a building site, if you lift 10 or 15 tonnes, that can be fairly heavy. Let's say a skipful of concrete might be 4 or 5 tonnes. That's very, very different from 4,000 tonnes.
It's exciting. You're working with the biggest crane of the world. It's like a Ferrari in the crane world.
When we lifted mud module 1, the crane, the slings were taking the tension. Just as it was just slightly going up in the air, there was an almighty groan from the module, as if you're not taking me away. I'm not having any of this. And then it managed to pull it away about half a metre, then it just stopped. It all balanced out. But for about 10 or 15 seconds, we were wondering what the hell was going to happen.
None of those lifts went wrong in any way. They were so well managed. So you built up real confidence, but again, not being complacent.
You're talking maybe 20 minutes, half an hour maximum for a lift. Some of them were only 10 minutes. The preparation's obviously a lot longer, but the actual lifts themselves, you're looking, you're just watching it moving around, but after a few, you're going, they've done it again. They've got all the figures right, and they've got the people out there who know when they should lift and when they shouldn't lift. It was great to be part of it. For them, it's another day's work.
I've been in this industry for about 22 years now. I haven't seen quite such a dangerous environment than what I've seen in North West Hutton. There was all the hazards you could imagine, and then the unknown hazards of demolition.
When you're removing a module, That goes away and you're suddenly on unfamiliar territory. And as well as that, we have a gigantic heavy lift vessel, which is also moving position around a platform. All your orientation is completely out.
It's getting smaller and smaller, the platform. And at the splices, you're looking down and you're going, bloody hell, there's a gap there. It's not as if you're on the same platform day after day. Your eyes are just popping out all the time to see what has changed.
Perhaps the most dramatic of lifts were the drilling derricks.
To lift the drilling derrick, we need to have perfect weather conditions. This means almost flat calm seas and very little wind speeds. When we've got the perfect conditions, we have a team of rope access technicians that climb to the top of the drilling derrick. We have the Hermod crane come along, they attach the lifts and strops. We have a burner who burns the 4 bolts away, makes the area safe. The crane then is free to take away the drilling derrick.
You're going to go up there, do your job. Good fun. Enjoy it when you're up there. If you're not scared, you're doing it wrong.
So our part of the operation involves connecting the slings to the lifting trunnions, which are on 4 points up at the crown block area of the derrick.
It's close you can get to flying, isn't it? It's brilliant.
Hopefully it won't go through lunchtime, that's all I'm worried about.
Seeing the drilling derrick, which is such a huge structure, to see it being lifted off by one crane, it was just like a huge mechano set. And when you see that on the deck of a ship which holds 350 people and it takes up all of the deck space, you just realize the scale of what you're doing.
The topsides removal, very complicated, manpower intensive activity, complicated engineering associated with the lifting, complication associated with the marine aspects of getting large structures onto moving transportation barges. One of the final photographs that was taken showed the platform with its navigation aid in a sunset and actually looking at a module support frame on top of the jacket with none of the topsides that had been there 2 months previously. It was quite an impressive sight, quite an achievement.
I was actually there when we pulled away. First of all, I thought, well, what was the fuss all about? Considering the last 95 days have been so hectic. But then, yeah, it was quite sad. It was a 500,000 man-hours that just got into taking all that away. Plus, it's such a long time that I've been on it from the beginning. Yeah, a lot of memories.
6 months passed before the Hermod returned to remove the jacket.
The topsides was decommissioned largely a reverse of the installation, so the modules were taken off in the same way as they were put on. The jacket was very different. The jacket was launched and put in a single piece.
It was towed to a position close to where the template was pinned to the seabed. Then the jacket itself was ballasted by allowing water into the legs.
The structure is that big, there's no crane that could lift it out in a single lift, so what we have to do is we have to dismantle the jacket piece by piece.
Very early on in West Hutton's development, the decision was made that we would not use divers. What that meant was, therefore, we had to rely on remotely operated vehicles, ROVs, to take the cutting equipment to the cutting locations at depths of down to round about minus 100 meters. It's something that hadn't been attempted before on this scale.
They're actually trialling all the equipment that we're going to use in the North Sea and taking all the tooling they've developed over the last 18 months. They're putting it in the water here. They've made mock-ups of the jacket leg. They've made mock-ups of all the different elements that we're going to cut, and they're actually using them in the water here in Barrow and Furness. Obviously, over the next 20, 30 years in the North Sea, a lot of the older platforms are going to have to come out, and we actually have to learn how to do it safely. We have to learn how to do it cost-effectively, and the West Hutton jacket is the first chance we've been able to try all this stuff out.
What we did is develop new technology. So we had abrasive cutting technology, we had diamond wire technology, we had shears, 15-ton shears, like a big pair of scissors, basically, that you put into the water.
It's essentially a large guillotine, like you might use for cigars, but actually quite a bit bigger.
It's a 6-function hydraulic machine. You close the gate around the tubular, the blade comes out, it overlaps and shears the pipe in half.
There'll be things when we get down there that we didn't know were going to be there. There could be stubs in the way, things that were added to the rigging construction or in deployment that didn't get fully documented, that haven't been captured, that we're so far unaware of. We're going to cut an access window in this and have a look inside of it. Nobody's seen inside it for years, so what we're expected to find in there isn't necessarily what we are going to find in there.
So what Harriman All-States MCF have done, they've developed an abrasive jetting tool with a robotic arm that's physically going to cut a window in the leg. Its arm is going to go inside, and they'll use that arm to cut the internal pipes and hoses.
And then we have to come outside again and actually cut through the leg. We have to do that with a castellation like you see on battlements, on castles, so that when there's any currents or anything going across, the leg just doesn't slip off.
With everything ready, the first major section of leg was prepared for lifting. Months of planning went into this moment.
We'd made all the preparations, we'd made all the cuts to go into the final stage to attach the rigging to the crane and then to make the final 4 cuts in order to lift the top section of the jacket clear of the water. Over a 2-hour period, we see the structure rising and rising and rising. It did take a long time to be completely clear of the water. We started initially with 7 meters of structure above the water. The whole structure you see behind me is actually 32 meters in height.
Wow, it looked fantastic, I must say. It was the first time a structural element like that had been removed in the northern North Sea, and you see a totally unique set of marine growth on it. It's quite different to the sort of elements you see in the southern North Sea, and the scale of that structure in comparison to the size of the Hermod and the barge was very impressive, and it went very smoothly. Once they'd actually done the final cut, that was lifted through the air and set in the barge within 30 or 40 minutes. Really smooth, and it's a great testament to Harriman and its subcontractors for how they handle that piece of activity. Very safely, very smoothly. Excellent piece of work.
I think I described one leg very similar to a scene from Thunderbirds. It looked like a spaceship.
If working at sea was demanding, there was a new set of challenges for when the platform sections arrived on land. For every module, every piece of metal had to be disposed of. During 2008, module after module arrived at the Able Yard, Teesside, northeast England.
It was obviously very clear that each module section was lifted off to a plan. It came apart really like Lego blocks, really. What we received was a very uniform modular sections which we trailered in to be disposed of.
We've gone offshore with the Hermod, we've taken the modules off. We've put the modules onto transportation barges and they've come here. And what we see today is the last stage of the journey, really. We'll start the demolition process and the recycling of the materials.
We go through a waste hierarchy of trying to reuse the components that we can first on either other platforms or other parts of the structure, then recycling the maximum amount.
It's not glaringly apparent on first visitation, but there is a skill and a regime in cutting scrap metal on this scale. There's a logic to it. It isn't just a bunch of crazy guys with cutting torches who just go in and cut where they will. There is a way of doing things. There is a regime.
In 2009, there were new arrivals at the yard. West Hutton's legs.
What we're seeing today is a jacket loading, which is really the finale of the actual West Hutton jacket coming in.
The jacket section came in one large section, the top jumbo section, and that was relatively easy to trailer in and manoeuvre to process.
It's going very slowly, some 1 mile an hour as it's moving off the barge.
Below the top section of the jacket, we had the legs and brace sections which came in piecemeal, and we had to deal with those by a heavy lift crane.
What you see here is taking off legs of the West Hutton platform that the Hermod barge, the Hermod, removed offshore.
There's a lot of weights here. The pile guides, when the jacket was first built, they're clustered around the pipework or the leg.
This is quite a complex lift, but pleased to say the engineering's worked out fine. The COG, they got spot on, I think a few millimetres out, but we won't argue about that. And it's lifted down horizontal and well.
It looks a very simple operation to bring it across, but it doesn't describe the full complexity of all the engineering that went before it and during to ensure that it's a very safe success.
What I think interesting about it is all the sea particles, the sea stuff, the shells, and that's something that you don't see in a new building in a fabrication yard. The dirty legs and the smell. It smells like oysters. I think it's not bad. I kind of like seafood.
For some reason, I expected the whole thing to be totally covered in seaweed and barnacles. What we actually found was that it was only the 10 to 20 metres below the sea surface that actually had a lot of growth on it.
When you see how it arrived, and to see it now in piles of ferrous metal, alloys, brass and copper and so on, and you see all the processing that's going on, it's very good to see that that has now been processed for new products.
We brought in 18,000 tonnes of modules last year. We've reused many of them. We've recycled a lot of them after we've removed the waste in a controlled manner. And so far, we're expecting that the recycling rate will be well in excess of 98%.
But also in a lot of cases, we're actually reusing the materials as they are. The accommodation module, which is one of the largest modules that was taken from West Hutton, has actually been renovated and is now an office accommodation block at the Able Yard.
I do remember going into the accommodation module down at Topside and seeing the old lockers of the workers there with their names on it, and because it had been transported, all the lockers were sort of on their side. That was quite sad and sort of nostalgic.
With regards to what will it become in the future, this will probably end up being recycled as steel, which will go back into the automotive industry, steel industry, for buildings, bicycles.
Seeing it being reused and seeing things being sold, it's sad but also good to see the reuse.